Hello, everyone. My name is Reihaneh Aghamolaei, and as Martina said, I'm lecturer in the School of Mechanical and Manufacturing, Faculty of Engineering and Computing. I'm so happy to be here, and I have learned a lot from this morning. What I'm going to present is about my experience about digital transformation in one of large-scale modules that we have in our school to improve active, inclusive, and sustainable learning. So I will start with the challenges and motivation that I have, and then move on to the actions that I took throughout this module. So just give you an overview and context to the modules that I applied these changes to it. So the module was Engineering Mechanics Dynamics. It's delivered to the second-year students at mechanical engineering. So it's a large-scale module. Usually we have 170, 180 students enrolled in this module. So practically all the mechanical engineering students have to do this module. So the first year, I've been delivering this module for the last 4 years. The first year that I was lecturer for this module, I did a quick feedback at the end, and I asked for the feedback from students to see the challenges they have. And based on that, I was able to identify the core challenges that students have in this module. So this module is mathematically demanding. So traditionally, we have low engagement for that because it's a difficult module. So obviously, low pass rate for students. The main challenges that students have in this module is a very simple thing, but they had problems to navigate through the content of the module due to the high cognitive load. So they had to study the lectures, they have to attend tutorial sessions, solve practical questions, attend labs, and do experiments, write lab reports. So some of them were confused throughout all these action, and because of that, we had low engagement. So we have limited time for personalized support for all these students. As I said, lab was an important part of this module, but we have some physical capacity problems, so insufficient space for all the students to attend the lab. Obviously, that was not a student's problem, but still was a challenge. And as a result of all these things, we had low attendance and low confidence for the student. So when I saw these challenges, my goal was to create an active and inclusive learning ecosystem and experience for this student, and not just digitize the module. So to address these challenges, I had some motivation grounded in the literature of large-scale teaching. So to address the challenges, obviously to help disadvantaged students, to get sure that they are keeping up with other students, to get sure that this high cognitive load of this module will not reduce the engagement for all the students, get sure that the diversity of the needs of all these students is addressed, and obviously to get sure that I have capacity to address these challenges. I wanted to reduce any duplication, wasted efforts, and physical resource limitation that we have. To do that, I had a framework. I developed a framework myself, which included a couple of actions. Started from very simple action that it seems obvious, but had a very significant impact on the student. The first thing that I did was I redesigned the loop, the loop page for this module, because that was the only point of contact that we have with students. So instead of uploading everything randomly on the page, I developed purpose-built hubs on the loop page, including learning hubs, problem-solving hubs, labs, and external resources. So students could navigate through these hubs and exactly find what they're looking for. For example, if they want to look at the theories and principles, they navigate through the learning hub. If they are happy with the principles, but they want to implement that theories in real cases, they go to the problem-solving hubs. labs, that was another hub. And also I added external resources to the Loop page instead of just introducing the textbook. So I contacted the publisher of that textbook, Wiley, which is a famous publisher for engineering books, and I asked them for helping me to integrate their multimedia support that they have. So I integrated Wiley Plus multimedia support for students, so a student could log into that support to that page and see the tutorials, labs from the Wiley. So that was the external resources that are involved. And as a result of that, by improving the clarity, students have more confidence and definitely have better engagement. In terms of the improving the learning experience, and to get sure that everyone is keeping up with the module, I combine, so this module is fully delivered in person. I developed mini lectures, recorded mini lectures, and uploaded to the Loop page before each session. So students have an opportunity to review the main and core principles of each session before attending the session. In addition to the tutorial sessions that I solved problems, I recorded some work examples broken into the logical steps to get sure that students that have difficulty to understand the question in the session can watch the videos by that logical step. How I found that these are the logical steps? I contacted again Wiley, and I had some consultation from them to get sure that I'm following the logical structures, because they have a difficulty index for all their questions for their textbooks. So I just wanted to get sure that I'm addressing the difficulty index for my question as well. So definitely pauses throughout the question, throughout the work examples, to get sure that students have time to understand it. So and I use it as a pre-class preparation. And my last action was to move on some of the in-person labs to online labs. So we didn't remove online labs. Definitely mechanical students need to be familiar with the tools. They need to be able to do the labs in person. But to get sure that they have experience of, they have the same experience and they have enough time to do the labs, I moved 2/3 of physical labs to the online labs, and I use to evaluate the labs, I use the new AI quiz. It's not new now, but it was new now last year, AI quiz generator that was developed by Teaching Enhancement Unit to include more questions for the labs. And there also definitely was feedback for students at the end of each quiz. So in this phase, all of the students had the chance to receive equal lab opportunities in addition to the in-person lab and the lab reports that they have to do for their in-person lab. And that was more sustainable way and scalable way to get sure that all students have enough time to do the labs. So as an impact of my work, so I checked the attendance for the tutorial and lectures. So by average, the attendance increased, a significant increase in the pass rate. And I think that was the direct impact of lectures, recorded lectures, adding external resources and recorded tutorial sessions. And also I asked for the feedback from students that I think I included here. I asked about how students feel to navigate through the lab, through the Loop page, and that was one of the feedback that I received. That's the most organized module I've ever taken. So definitely it's a starting point for engineering modules. We need to reduce dependency on physical labs while we are getting sure that students have enough experience in the physical labs. More efficient use of resources, and definitely promote self-regulation, system thinking, and digital literacy in my modules. But definitely for the next steps, I need to include more metrics to get sure that what I have measured for the last semester is consistent, and I will have the same results if I do this approach this year. Thanks very much.